Okay, this video is a continuation of our look at geometric sequences, and by the end of this video you should be able to find the partial sums of a geometric sequence. Now remember that we've been looking at arithmetic and geometric sequences. An arithmetic sequence is one where each term is obtained by adding a constant to get the next term, and a geometric sequence is a sequence where you get the next term by multiplying by a constant r. Arithmetic, you're adding a constant difference. Geometric, you're multiplying by a constant ratio. Also remember that we took a look at some partial sums of arithmetic sequences. We used this formula, which we came up with by adding up all the numbers from 1 to 100. So today we're going to look at partial sums of a geometric sequence, and there is a proof for that, but I'm not going to take the time to tell or explain it to you. It's a little more complicated than the arithmetic sequence, and what I want to do is just focus on practicing how you use this formula. So just like the other one, you're finding the sum of a sequence from 1 to the kth term. That's why it's the kth partial sum. To do that, you find the un that's equal to the first term multiplied by 1 minus the ratio to the kth power divided by 1 minus the ratio. So that's the formula. So here's an example. If I tell you that I want you to find the kth partial sum, and I give you the k, and I give you the first term, and I give you the ratio, well, you could write it out if you wanted to. The first term is 5. The next term you get by multiplying by 2, so it's 10, times 2 is 20, times 2 is 40, times 2 is 80, and so on. You could write out all 6 and then add up all 6, and in this case that might be doable, but the formula says that you should find the sum from 1 to 6. You're going to find that by taking the first term, multiplying it by 1 minus the ratio raised to the k over 1 minus the ratio, like that. So if you know the formula, all you have to do is put in the numbers that you know, which in this case you know first term is 5. That's this, multiplied by 1 minus the common ratio is 2 raised to the k, which is 6, over 1 minus 2. Now you may or may not be able to do some of this work in your head, but the more work you do with paper pencil, then the easier it is to get the right answer if you have to use a calculator. So I'm going to try to do as much as I can without using a calculator, like 1 minus 2, that's negative 1. 2 to the 6th power is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, that's 1, 2, 3, 4, 5, that's 64. So 1 minus 64 is negative 63, and 1 minus 2 was negative 1. That's multiplied by 5. Negative 63 divided by negative 1, that makes that positive. So really all I have to do on the calculator is figure out what's 5 times 63. 5 times 63 is 315. So my answer is 315. Now, that's a pretty simple partial sum of a geometric sequence. Here's one that's a little more complicated. It looks just like the last one we did, only instead of giving you a common ratio that's a whole number, it's a fraction. So if, again, you wrote this out, it would look like this. First term is 5. 5 times 1 half is 5 halves. 5 halves times 1 half is 5 fourths, 5 eighths, 5 16ths, and so on. So adding these up by writing them all out is not as simple as adding up a whole bunch of whole numbers. So we're going to use the formula again. You're going to find the sum of the first 6 terms of this geometric sequence, which will equal the first term times 1 minus the ratio raised to the k divided by 1 minus the ratio. That's just a formula. If you just write it down over and over again, you'll remember it. So, plug in what you know. You know that the first term is 5. 1 minus the ratio is 1/2 raised to the 6th power over 1 minus 1/2. And again, you try to do as much as you can without using your calculator. So 1 minus 1/2, that's just 1/2. Now 1/2 to the 6th power, you might be able to do that, and I can do it, but I'm going to show you how to use the calculator. So 1 minus 1/2 to the 6th power. Now what you see on the screen is a graphing calculator, but you can do this with the scientific calculator or even the calculator that's on your computer. And you go like this: 1 minus, if you use the parentheses, oops, let's try that again, 1 minus parentheses. If in the parentheses you just write the fraction out as a division, like 1 divided by 2, and then you raise that to the 6th power, the raised to the power of is the caret key on this calculator, but yours might be a little key that looks like this, y to the x. Raise that to the 6th power. That's that. Then you're going to divide that. So you hit divide, takes the previous answer, divide that by 1/2, 0.5. Then you're going to take that answer and multiply it by 5 times 5. And that gives you your answer. 9.84375. So, the kth partial sum of this geometric sequence is 9.84375. Now, your assignment is going to look like this, which is a little different than what I just gave you. So I want to show you how to do that using the first problem as an example, and then you'll just have to do the other 5. Well, do all 6, but I'm giving you one of the answers. So this problem is asking you to find the sum. Find the sum of this problem. This is the UN. So to find the sum, the first thing you have to do is figure out what's the first term. So if you put 1 in place of n, 2 to the first power is 2. Now you might be able to look at it and tell me what the ratio is, but just to be sure, let's find the second term. The second term is if I put 2 in place of n, 2 to the second power is 4. That makes my common ratio 2. Because to go from the first term to the second term, I multiply by 2. And you should be able to notice that because it's right here. So in problem number 30, the first term is whatever you get when you put 1 in for k. 1/2 to the first power is 1/2, times 3 is 3/2. The ratio is 1/2. So once you figure out the u, 1, and the r, the k is given to you right here. Then you just put all those numbers into that formula, which is u1 times 1 minus r to the k over 1 minus r. Well, I changed my mind. I think I'm just going to stop there and let you figure out the answer to number 29 now that I've given you the variables that you need to put it in the formula. The rest of these are the same. Use your calculator, come up with the answers, and that's it.